Hey again, it's Mr. Lum, and in today's lab we'll be looking at the reaction rates. In particular, we'll be looking at the reaction rate between magnesium and hydrochloric acid. So right here we have a balance. In the beaker is hydrochloric acid, and also on the scale is some magnesium. So the initial weight of all of these things is about 15.68 grams. So we'll start the reaction, and what I'm going to do here is I'm going to place the magnesium into the hydrochloric acid, and then we'll start the stopwatch and figure out what the reaction rate is over time. So magnesium goes in, and this is the part where I fumble around with the stopwatch, and then I place the stopwatch in a position so it's really difficult to read. So what I did for this reaction is I actually used the timer on the camera that's taking the video in order to calculate the reaction rate, and I didn't actually use the stopwatch. But as we see, the reaction proceeds, and magnesium and hydrochloric acid are reacting together. And we have here's the formula for the reaction. And what we see is magnesium and hydrochloric acid are producing magnesium chloride, and the bubbles that we see are hydrogen gas, so that plus H2, that hydrogen gas is being released. This is an exothermic reaction, so we see this is getting pretty warm, and the water is getting fairly warm as well. And the other thing that we notice is that, at the beginning of the reaction, our reaction was at 15.68 grams for our total mass of all the reactants going into the reaction. And then we see now everything is there, everything's been on the balance, and we're at 15.06 grams. So all the mass that we're losing is from the hydrogen gas that's being released. So we can then, if we were to collect all this data, so what I've done here is I've collected data at 10-second intervals, and at every 10 seconds I've just recorded what is the mass of everything there. So we'll let this reaction kind of proceed. It's pretty much done right now, and I think since the reaction is a little bit exothermic, the balance is kind of going down just because maybe the evaporation of water. But reaction is pretty much done. And yeah. So I've taken the data and I've graphed it right here. And what we see at the beginning of the graph is that it's quite steep, and then it kind of levels off at the end. And this is because the concentration of HCl is decreasing, and the concentration of magnesium, well, not so much the concentration, but the surface area of magnesium is also decreasing, and therefore the reaction rate is decreasing as we go. So we see the reaction rate is pretty steep at the beginning, and so therefore the reaction rate is fairly high, and then it starts to level off, and kind of towards the end, around that between 110 and 120 seconds, it starts to flatten out, and the reaction rate gets less and less because the amount of reactants is being used up. The concentration of HCl is decreasing.